This video will help students complete problem 1.3 in the Looking for Pythagoras book. Problem 1.3 deals with finding the area of unusually shaped objects. For that purpose, we have given students lab sheet 1.3. So before you finish watching this video, you should get a hold of a copy of this. It's either in a student notebook or it's on my website. There are two main ways to find the area of unusually shaped objects, and I'd like to explain both of them. We'll start by doing question number 6. The first method is what I call chunking. That really means that I break the unusually shaped object into small chunks that I know how to find the area of. If you look at the figure in example 6, we don't have a formula for the area of that shape. So what I do is I break it down into areas that I know. So for example, I'm going to make a rectangle that I know is worth 2 square units here. And then I'm going to break it into other small pieces, like this half of a square up top, and I'm going to write 1/2 there. So I break it into chunks. Now the leftover part is a triangle. There's a couple different ways to do that. First way is to use the formula for the area of a triangle, which is base times height divided by 2, or 1/2 times base times height. And the base of that triangle is 3 units long, and the height of it's 1. So I would say 3 times 1 is 3, and then divide that by 2 and you'd get 1.5. So the total area of this figure would be 2 plus 1.5 is 3.5 plus 1/2, or 4 square units. And you can write that units to the second power for square units, or you can write it SQ for square units. The second method to find the area of an unusually shaped object is what I call subtraction. Subtraction involves making a rectangle, the smallest rectangle around the figure in question that encloses it all, and finding the area of that whole rectangle first. So this rectangle would be a 2 by 3 rectangle, or it'd have a total area of 6 square units. The next thing I would do then is to chunk off the pieces that I don't want. That would be the white area as opposed to the shaded area. So just like before, I'm going to find the area of these pieces. So in the upper left corner, I'm going to shave off this 1/2 of a square there, and the same thing in the lower right hand corners. There's another half. Then I need to find this triangle in the upper right, and since that's half of a rectangle that has an area of 2, that has an area of 1 for the triangle. So if I combine those, I'm subtracting 1 plus 1/2 plus 1/2, or 2 square units from the big rectangle. And 6 minus 2 gives me the same answer we got from the other technique, which is 4 square units. I find it best that students use both of these techniques when finding the area of unusually shaped objects. You'll find that sometimes one method won't work very well for a particular shape. For example, if you look at question 9, this funny shape here has some area that's hard to determine if you do chunking. So I can chunk out things like this rectangle pretty easily and find an area of 3. But when students try to chunk out areas, parts of the square, for example, they don't know exactly how much of the square is being shaded. It's not exactly half and it's not the whole. So they end up estimating and not getting a precise answer. So in those cases, we tend to want to use the other technique. So in this case, a better way to do question number 9 is to use the subtraction method. So first I will box it in the smallest rectangle that holds the whole figure. And that's going to have a side length of 4, which, by the way, we need to count the spaces between the dots to find the length, not the dots themselves. So that has a side length of 4, and the other side is also 4. So that is a square that has an area of 16 square units. Now what I'd like to do is eliminate the parts that I don't need, and that would be the white spaces. I like to think of this as a big block of ice, and that you are making an ice sculpture that is the shaded area on the inside. And so when you're sculpting like that, you want to shave off the parts that you don't want, leaving the sculpture inside. So I want to shave off the unshaded white parts. So I'll begin by this corner here, which has an area of 1. And then I might do this little triangle down here that has, since it's a base of 3 and a height of 1, 3 times 1 divided by 2 is an area of 1.5 square units. Then I know the tricky part to this one is this triangle and this triangle here. So if I enclose that in a rectangle, and the rectangle has 3 square units, you can count those there, then that triangle is exactly half of that, or another 1.5 square units. And so this would be the same on this side. Then I still need to shave off this little section here. That is half of 1 square. If you look at that triangle, that is 1/2 of 1 square unit. And if I could chunk this out a little bit, that little piece is also 1/2. And this triangle here is 1/2, as is this one. So now I've got a total of 1.5 and 1.5 here makes 3, plus that one is 4. Down here, that'd be 5.5, then 6, 6.5, 7, and 7.5. So I started with 16 square units on my square, but I subtracted out 7.5 square units, and that leaves the shaded part with an area of 8.5 square units. And that is a precise way to solve the area of that unusually shaped object. I hope this video has helped you find the area of unusually shaped objects. You can find this and more help at my website at the address listed above.